So now that we've talked about exponential functions and we know all about linear functions, we're going to compare the two. So by the end of this lesson, you should be able to identify whether something's linear or exponential, and then write an equation for each of them. So this is something we've done both in their separate sections, but we're going to kind of put it together. And your notes look a little funny because I want you guys to compare them. So let's first talk about a linear equation. Linear functions can be written in the form y equals mx plus b. So if you can rewrite something in this form, it's going to be a line when you graph it. And remember, your m stands for your slope, which is your rate of change. And your b stands for your y-intercept. So it's always like 0, comma b, and that's your starting point. So jump down to the very bottom of the linear part, and you have this example. Don charges a flat fee of $5 to mow a lawn, and then $8 per every hour spent. Write an equation to model the data. So when I read this, I see the flat fee, that's going to be our starting point, and I see this rate of change, and it's $8 per every hour. That's going to be our slope. So this equation is going to be y equals 8x plus 5. So if I mow for 0 hours, I charge $5. If I mow for 1 hour, I charge the 8 plus the 5 for a total of 13. So how do you know a table represents a linear model? Well, remember, in a linear model, we have a slope, and that slope is rise over run. Rise is our change in the y values, and run is the change in the x values. So let's take a look. The change in my x values in this table, it goes up by 1 every single time. So that's my change in x. My y's, to go from 7 to 3, I need to subtract 4. Double check that that works for every single one here on the table. So -5 minus 4 more does give me -9. So my change in y values is -4. So my slope here is -4. Now I could write an equation with this. The only other thing I would need would be my y-intercept, which remember is when x equals 0. So if I add 4 here, I end up with 11. So my equation for this would be y equals -4x plus 11. What does the graph of a linear function look like? So if we were just to plot these points, over 1, down 3, over 2, down 1, over 3, up 1, remember a linear function looks like a line. So that slope gives you your up and over, and our y-intercept tells us where to start. So all of this should definitely be review. This part we even did when we talked about linear things. Is a linear model arithmetic or geometric? So take a look, how do I go from 2 to 5? I could add 3. Now if I double check that this works all the way across, now I know it's arithmetic. And remember, for an arithmetic sequence, I can use this formula to come up with an equation. So I have a of n is my first term, plus n minus 1, and my common difference was that positive 3. Because the simplification makes it nice and pretty, we always tend to do that. So our equation here is 3n minus 1. So now to write an equation of a linear function that passes through 2 points, remember the two things we need are the y-intercept and the slope. Now, neither of these points are the y-intercept, but they can help us find the slope. Remember, to do this, you can use the actual slope formula, or you can put the points on top of each other like this, do the little L thing, and subtract. So we get 6 over 3, which is 2. So now, in my equation, I have this much. I still need to find the b, my y-intercept. So to do that, you can plug in a point. And it doesn't matter what point you plug in. Let's pick 3, 4, because those numbers are a little smaller. So 4 is my y, 3 is my x. This gives me 6. So if I subtract 6 from both sides, I get negative 2 is my b value. So this is my equation that would go through those 2 points. So hopefully all of that was a nice little review. And now let's talk about exponential functions. So remember, exponential functions can be written in the form y equals a times b to the x power. This time, a is our y-intercept, or our starting value, and b is our growth factor. Now, a lot of people were getting growth factor and slope mixed up, but remember, for this, we are multiplying. We are not adding, so it's going to get bigger much quicker. So go on down to the bottom of the exponential part, and Betty went to school with the flu. The number of people infected doubled each day. Write an equation of the exponential model. So it's got to fit this, a times b to the x power. So our starting value was just Betty. There's just one of her. And then the number of people doubled each day, so our growth factor is 2. Now, most of the time when you get something like this, it's just written y equals 2 to the x power, but you can definitely write the 1 there if you want. So, how do you know a table represents a linear model? Well, for this, we're going to need something that is not a slope. So when we look at our change in x, just like before, our change in x is still plus 1 all the way down. But this time, we're not subtracting the same thing here. So these numbers are a little smaller down here. We could do this. This would be minus 2, but this would be minus 6. And this is minus 18. So these numbers are different. Now, when that happens, when your numbers are different, look for something that you could multiply by. And if you take 81 and multiply it by 1/3, you get 27. 27 times 1/3 gives you 9. 9 times 1/3 gives you 3. And 3 times 1/3 gives you 1. So this right here is our growth factor. That's our b value. So if I wanted to write an equation, this is what I have so far. Now remember, we need the y-intercept, so we got to go backwards to find that. So instead of multiplying by 1/3, we're going to divide by 1/3, which remember is the same thing as multiplying by 3. So if you type in 81 times 3, you get 243, and that would be our a value. And now remember, a graph of this, if we were to go and graph this, just plot all these points on here, it's not going to give us a line. Instead, it's going to give us a curve that's going to start shooting up quicker and quicker. Remember, it has that asymptote, so draw it really close to the x-axis, but not going over it, and then it shoots up very, very quick. So is a linear, this should say exponential, is an exponential model arithmetic or geometric? So remember, if it's arithmetic, we're going to add the same thing every time. And we can quickly see that we don't add the same thing every time. So it has to be geometric. And instead of adding the same thing every time, we're going to multiply by the same thing every time. So for this one, we can write a sequence. A sub n equals our first term times our ratio to the n minus 1 power. And when you plug this in, you end up with our first term is 2, our common ratio is also 2 to the n minus 1. Now remember, you could simplify this, but we're not going to, so just leave it like that. Last thing, we need to write an equation of an exponential function that passes through these 2 points. So remember, the 2 things we need to write it in this are the y-intercept and our growth factor. And it just so happens that one of the points they give us is the y-intercept, 0, 2. So that's going to go right here in our equation. And now the other thing I need to find is just my growth factor. So you can make yourself a little table, 0, 2, and 1, 6. This went up by 1. And in order to go from 2 to 6, remember we're doing multiplication, not addition, I need to multiply by 3. So that has to be my growth factor. So write down any questions you have and we can go over them together in class. Enjoy your weekend.